Okay, guys. I did promise last time that we're gonna be solving problems on momentum the next time we meet, and so I'm going to be using solution for all physical sciences. All right. So if you do have it, you can also check on your um on your own textbook, right? Okay. Um, so we're gonna be checking on page 15. Okay, page 15. If you do have this textbook, you can also check on your textbook and try to solve these problems and see if you get the same solutions. You can even pause the videos as you try to solve the problems on your own, and then you check if our solutions are going to be the same, right? Okay, so last time I did teach you that momentum will be represented by the letter P. So P stands for momentum. And the SI units are kgs, meters per second, right? All right, if you guys still remember, we said the letter P will represent momentum. Okay, and we said momentum is equals to mass multiplied by velocity. Okay, where m stands for mass in kg and v stands for velocity in meters per second. If you are having trouble with this, you can check the previous video. All right, so we said momentum is the product of mass and velocity of an object. Therefore, because it's the multiplication of mass and velocity, the SI units of momentum will be kg meters per second. All right, let us check to let's try to solve this problem. Here they say calculate the momentum of a 1300 kg rhino galloping east at 15 meters per second toward a poacher. Right, so I did tell you that you must start by writing data. Okay, so the mass of the object is 1300 kgs. Okay, and the velocity of the object is 15 meters per second toward the poacher, and they say this east toward poacher, right? That's what they said. And they said you must do what? You calculate the momentum. Okay, so let us calculate the momentum here. We know that P is equals to mv, right? So m is 1300, and v is 15. Okay, and if you say 1300 multiplied by 15, punch on your calculator and you find that it is 19,500. The SI units, remember, of momentum, kg meters per second. Where is it going? If you can remember, last time I did tell you that the direction of velocity will be the direction of momentum, because momentum gives, velocity gives momentum its vector nature, right? So the direction will be east. Right, so the direction will be east. The direction of momentum is the same as the direction of what? It's the same as the direction of your velocity. Okay. So even if you decided to choose direction and say, okay, I choose east to be positive, west to be negative, or you choose east to be negative and west to be positive, you'll get the same answer. You'll find that you still get that the direction is east. Okay, let us check another problem here. Okay, there is the solution. As you can see here, 1300 mass, 15 velocity. They chose east to be positive here. That's why you have plus 15, and then you find that you have positive 19,500, and then you write the SI units kg meters per second east, because velocity is east, momentum also has to be east. All right, now figure 1.3 shows some bumper car. One of the cars has a mass of 180 kg and is carrying a 70 kg driver. Okay, it has a constant velocity of 3 meters per second and it is going to the west. All right, so this is what we have. Basically, you have a car here. This is your car. You have a car and there's a person inside the car. All right, and they tell you that this person has 70 kg and the car has a mass of 180 kg, but they say they are moving with a velocity of what? Of 3 meters per second. They move with the velocity of 3 meters per second. Guys, remember, when the person is inside the car and the car is moving at 3 meters per second, the person will also be moving at what? At 3 meters per second, according to Newton's first law, right? So the person will be moving with the car at the same speed. Okay, they will have the same speed. All right, so we know that the person is moving at 3 meters per second and also the car is moving at 3 meters per second. They have to have the same velocity. Okay, so if you are inside the car and or maybe inside a taxi, you are going to town and the taxi is moving at maybe let's say maybe 80 kilometers per hour, right? And you are seated in the taxi. You and the taxi will have the same speed. You'll be moving at the same speed of 80 kilometers per hour. That's why the taxi suddenly stops. You'll move forward. Why? Because you still continue with that same velocity that the taxi was moving with. Right, so this is the reason why we say the person inside the car is also moving at what? At 3 meters per second. Right, let's check the problem. They say calculate the driver's momentum. They want us to calculate the momentum of this person, not the driver in the car, but the person inside the car. All right, so when you calculate the momentum of the person or the driver inside the car, you know that the equation says that P is equals to mv, right? So P is equals to mv, and the mass of the person or the driver is 70. So you have 70. The velocity, remember I said, is gonna be what? The same. So the person is also moving at 3 meters per second. So now you can say, okay, you can say 70 multiplied by, let me open my calculator here. You can say 70 multiplied by 3. Oh, this calculator, sorry. All right, so you say 70 multiplied by 3, you get 210. I hope you get the same answer on your calculator as well. So you have 210 kg meters per second. But what is the direction here? Let us go back to the statement. Remember, the direction of velocity is the same as the direction of what? Of momentum. Velocity of 3 meters per second west. So it means the direction of momentum will also be west. Okay, and you are done. All right. Number B, they say you must draw and label the driver's velocity and momentum vectors. Okay, I'm going to teach you that on another video. Let us go to number C. We'll come back to the to the vectors later. I will teach you that separately. Okay, number C, they say you must calculate the momentum of the driver bumper car system. Okay, so when we talk of a system, we are referring to both the car and the driver. They form a system together. Okay, so this is a system. So when they say the bumper car and the driver system, they want us to combine both and use them as one. We use them as one, right? So we first have to write our data, and we say, okay, our data, our mass will be because we combine them. If you say something is a system, you combine everything there. So we have 70 plus 180. Okay. Okay, so this will be 250, right? So 250 kg meters per second. Kg. Sorry, this the units of momentum. I'm just writing mass. Okay, so it's 250 kg. All right. So that is the mass of the system, and the velocity. Remember, they both move with 3 meters per second. As a system, they are all moving with a velocity of 3 meters per second. Now let us calculate the momentum of the system. So say P is equals to mv, and m is 250, velocity is 3. Okay, so if you say let me see, just want to check. $250 multiplied by 3, you get 750 kg meters per second. Where is it going? It is going west because the velocity is to the west. So remember, the direction of velocity is the same as the direction of your what? Of your momentum. Okay. And number D, they ask, how will the momentum of the driver car system change if its velocity remained unchanged but another person was also in the car? Explain your answer. All right, we know that momentum P is equals to mv, meaning that momentum depends on what? It depends on mass and velocity. So they say, how will the momentum of the driver car system change if the velocity remained unchanged? The velocity remains the same, but they add another person, meaning they increase the mass. So if mass increases, what will happen to momentum? Right, we know that momentum depends on mass and velocity, right? So if they increase the mass, momentum will also increase because it depends on both mass and velocity, and because mass has increased, momentum will also increase. All right, so that's how you're supposed to answer that question. I hope it was helpful. If you have any questions, you can just type on the comment section and I will be happy to answer you.